scream hey, about like just trying to rip each other off. It's just how it works.
Yeah.
It's great.
Right.
Going to that to help people. Most amazing thing I've ever experienced. Yeah.
Waking up.
Just rewarding, yeah, and like people are just glad to see you because when you're like kind of better than that industry, you get rewarded for like sneaking things past people, which I didn't love.
Yeah.
You know, all the deals behind closed doors. I didn't love that, so I'm really stoked with it.
That's kind of an interesting niche market.
Yeah. There's not a whole lot of those in existence, but we started 3 years ago. We started online first during COVID, and then now we have one building, and then filled it up really quickly. We got another building, that thing up quickly, and now we're like working at two staff.
Jim, right?
Yeah.
Jim, right. We met before. We know when he was redoing that one.
Oh, yeah, did electric one?
Oh,
yeah.
I've seen you at a couple.
My manager, all the other
That's it. You go round up the last few people. I mean, good.
Good.
Good, right on. We didn't see you at Evolution before. Thursday.
Yeah, I was going. Yeah. You know, a lot of times I can't make it right.
Yeah.
I try to. If Shanu will talk to me, I'll come. Yeah.
Sure. Run that up for sure. Okay. That's awesome. It was really fun to like tinker and settle. Yeah. Like kind of. Yeah. I mean, obviously we did. But yeah. Now it's getting to a point where we can stop spending money.
Yeah.
And that's why we ended up in the house and all that other stuff too. Yeah, I absolutely. Sure. Cool. Great. Yep. So if you see that car, that's me. So that one,
I think I saw it before.
and then I had this 2012. I was brought out. It's better. And it's not. Very like small, lightweight. And then my brother has this car. That's in the other house right now. Honestly, I should have planned out to take that car, and then I could talk about some of the heavy notices. Just show up in the easy one. That's really heavy. And that's what I drove today. The zero one. I would be fan of non-super cars, but it'd be that.
A couple more minutes here.
That's what you actually know. That's my first car.
Car over there. Window strip on it.
It's interesting to actually see that. And that's a dedicated, someone close car. Not street. All except for this one. The easy one is way better. It's like the other one.
They are. I mean, it's just the iteration. Yeah.
But that one's at the shop.
991s or 992. Yeah. It's like, I don't know why they call it so.
Like I told you, like when you use power a lot, things happen. So it usually breaks every time you drive it. Shut it off. And then deal with it in your relationship. Small changes are all new. Yeah, there's no side of the entry. Listen, it was a pretty good deal for a little bit, and I stopped the past year. And then they're like, hey, we need to see you out.
All right, guys, I think we're going to get started here shortly. If you want to take and grab a seat. Is all the technology ready to rock? Okay, excellent. All right, well, welcome, guys. I'm Shanu with InnoKinetic. Glad you guys are joining us here today for our technical seminar. I'm super excited to introduce our guest, Martin Meade from Girodisc. Martin and I have known each other for 20 years. I mean, Martin started Girodisc in 2003, And the year after that, we started working on our first brake solution for the Elise. And what really got me excited about Martin and Girodisc was his innovation. Anyone that knows me knows I really get off on innovation. And he came to us with some ideas that were out of the box. You know, the Lotus Elise, the brake rotor is the exact same part number on all 4 corners. Martin came up with an idea that would be different for each corner, but that allowed us to actually have a much lighter brake solution than anybody else offered in the entire world for the car. And so, these rotors have now, you know, they've stood the test of time. You know, these things last nearly 50,000 miles. We have customers getting 50 track days out of these rotors, so they're superb. So, without further ado, with great pleasure here, I'd like to introduce my good friend Martin Meade.
Thank you. Hi, everybody. Yeah, it's true. 2003 is when I got my business license, which meant I was legit. We met at Concorso Italiano in 2004, I believe it was.
Yeah.
And then by early 2005, I think we had some prototypes ready to go for the first Elise that you had, and we put them on Neil's car, maybe?
I think they were on mine.
Were they on yours?
Actually, yeah.
Yeah, and so what he was talking about was, you know, it was interesting to see that the same rotor was used on all 4 corners. And while that necessarily isn't a bad thing, because the cost accounting people like to see low tooling prices, right? And so if you can use one part over and over and over, that's a win. But when you have a curved vane design, right, where you've got a direction to the way the rotor should actually spin, and then you put it on the other side of the car and spin it backwards, it's not doing the same thing on the left-hand side as it is on the right-hand side. And so the other cost cutting measure they made was the front rotor was about this wide, the annulus, and you needed that for the pad, and then they just used the same on the rear. So you had a bunch of unswept area on the rear rotor that didn't need to be there, that was just extra added weight. And so we ended up making directional curved vane discs, and then this rear one being quite a bit thinner for the smaller pad, so that we didn't have so much extra unsprung weight that wasn't required. So yeah, that was, we're part number 029, I think, and we're up to part number 370 something right now. So we've got a lot of different applications these days. But anyway, I kind of recycled a presentation that we did for an open house that we had for another club, and so I'm going to see if I can make this work. It's working. So the agenda, we'll go over kind of the history of our company, what our philosophy is, our current capabilities, and what we do now for optimizing discs. And so this whole thing started back in 03. I was at lunch with a friend who was an engineer at Brembo. Brembo used to have a facility in Costa Mesa that they did all their distribution. And he was telling me that they were having a really hard time getting prototypes made. And I was working at Porsche at the time in the design studio in Huntington Beach. And I said, well, that's all I do is get prototypes made because we're building show cars. And so they started giving me drawings, and I would go to the machine shops that I worked with for making parts for our show cars and get these center hats, you know, like this part made, or maybe it was a caliper adapter bracket or something. And so then I would go over to Brembo and with an invoice and some parts, and after a year they figured out that I actually didn't own a machine shop, and so they didn't want to work with me anymore, which was understandable, I guess. But in the interim, I was like, you know, I noticed that there's a niche here that's not actually being filled, and that's a direct replacement disc to use with the OEM caliper, and that's a more race-oriented disc as opposed to a cost-conscious disc. And so that started Girodisc, and our very first part number was the 001, which was the Ferrari 360, and later became the 430, still use the same disc. And I didn't know anything about anything other than making parts. I didn't know how to run a business, I didn't know how to market or sell or anything, and so all that came over time. It was in Costa Mesa, and I think the first thing that really put our name on the map was I was always going to Cars and Coffee, always going to a show,
and I met the guys from evolutionm.net, and that was the biggest Mitsubishi Lancer Evo forum online. And it was a similar situation to what it was with Shinu. They were like, hey, can you make some brakes for our car? And I said, sure, the Ferrari things. We only made Ferrari parts in the beginning because I thought that was going to be a great idea. And that was a good idea from the standpoint of getting a little bit of street cred, like, oh, you make Ferrari parts. And then, well, they're probably good enough for my Mitsubishi then. But the Mitsubishi, those guys really helped us. And it just snowballed from there. And then it would go to the next application and the next application. But we did kind of gravitate right towards this two-piece direct replacement disc. So as long as your car was a performance sports car and it had a Brembo or AP caliper on it, we knew that we were probably going to be able to make an upgraded product. And so that's what we specialize in. Shortly thereafter, we designed a tool because there was a need of people to get all 6 of their pistons back in their caliper, right, to put the new pads in. And so we created this tool that almost looks like a post hole digger. And you kind of shove it into the caliper and squeeze these 2 levers, and all of the pistons retract at the same time. And so that came in 2005, and we've probably sold over 1,000 of those tools at this point. And they're not inexpensive because we hand make them. It's not something where you go to China and get it made. We bought our first CNC machine. Shinu knows this very well, as does anybody in small scale manufacturing. You're always in last place when you go to the machine shop. When you tell them you want 10 of something, they're looking for somebody that's got a 100-part order or a 1,000-part order. And we were always asking, I need 10 of this, I need 10 of that. And, because you don't know what's going to sell next week, and so you don't want to keep too much inventory. And so we decided in 2010 that we knew that the direction going forward was going to be we had to be able to do this ourselves in-house, and we had to become vertically integrated. And so we bought our first CNC mill in 2010. I had no idea how to run it. I just bought one, and I put it in the corner of the shop. And about 4 months later, somebody came in, a kid from the local university that made some inquiries, and then he asked, do you have any job openings? I'm like, do you know how to run that? And that started our first production manager. And he built our machine shop over the coming years. And so then the next step was, okay, we're starting to make things. Now maybe we need to actually make, because I was sourcing some generic discs that I knew some suppliers that I could get from, and maybe we need to actually start sourcing our own rotor iron. And so that was another stage, and that was another bit of naivete, because I thought it was going to be really easy to just say, yeah, it's going to be this big around and it's going to have some holes in it and it'll be great. Well, it turns out there's metallurgy, and it turns out there's the micrograph structure inside of the iron. Once it cools, you have to make sure that's right. You have to machine it flat, and it has to be a certain surface finish of roughness. How many veins am I going to put in there? What angle? So it snowballed. And we spent a lot of money on tooling and going to different foundries. And now we are with the largest brake rotor foundry in the country. They're out of Wisconsin, called Wapaka Foundry. And so now we've got that under our belt. And we now have 7 different rotor castings that are proprietary to us with our own proprietary metallurgy. And we machine those into all the multiple various configurations. In 2019, like Shinu, we bought our own building, and that was 17,000 square feet. You can see here that we've got a 75 kilowatt solar array on top of it that in the summertime would actually power all of the equipment in the place, which is astonishing because we have 18 CNC machines at this point. But you don't just get to call the landlord anymore when the roof leaks. You get to deal with that yourself. Our philosophy has always been, there should be no excuses. Just make it right the first time. Charge what it costs, charge an appropriate amount based on your cost to make it right the first time, and you'll attract the right kind of customer. We did that from the beginning. We only use US sourced everything. So it's US sourced aluminum, it's US sourced iron, US sourced hardware and fasteners. We have machines called Swiss lathes that actually make all of the drive hardware that holds the hat and rotor together. So that was something that we knew early on. We were not going to go to, I'm sorry. Early on, we did experiment with Australian supply, Taiwanese supply, and we recognized quickly that that's not a sustainable model if you want to have the quality that you know you need. So we only use domestic suppliers for everything, which was a boom during COVID, because when all the ships were stuck off of Long Beach, we were laughing, and we picked up a lot of business at the beginning of COVID because we were the only people who had parts. We have become ISO 9001 certified as of 2 Januaries ago, and that means that our vendor accountability and supply chain stability is all part of that ISO 9001 process. So we knew that we had quality procedures in place internally that we developed over the years, but this really took it to the next level and holds the people outside of our organization accountable as well as ourselves. And so that's something that we take great pride in, because that is not a small undertaking to become ISO certified. In-house manufacturing, like I said, we knew that we were going to have to be able to do this ourselves, and so we became completely vertically integrated. The only thing that we don't do in-house is the coatings, the platings, and we're actually investigating that right now, because anodizing shops have got to be about the worst to work with, because they are always late and they'll scratch your part or ding your part or drop your part or lose your part. And so that's another thing that we're going to be looking at. By bringing in this equipment in-house, we are able to now easily say, I only want 10 of that, or I want 60 of that, or I want this. Or maybe it's, as you can see this car right here, that was a situation where they were running at the 25 hours of Thunderhill, and a week before the race they realized they needed brakes. There weren't any in the country, and there weren't any in Italy. And so they called us and said, we need 2 car sets of rotors in 4 days. And so they overnighted us their original parts. We reverse engineered them, made them out of our raw materials that are all on the shelf, and we're able to ship it back out 4 days later. They were not anodized. The hats weren't anodized because we didn't have time to turn that around. But so they were able to make their race and had a couple car sets of rotors. So that agile aspect of it is very important for us. And recently, our rapid prototyping has got to a new level. We've always had a 3D printer for printing out plastic section of things and being able to test fit and whatnot, but we've been working with our foundry to develop modular tooling and even 3D sand printing. And so we can now create a new design, and they can 3D print the cores and patterns in sand and then put those into the production manufacturing environment and pour just as if it was a production part, but using rapid prototyped things. So instead of $35,000 and 14 weeks for new tooling, they can print something out for a few $100 in sand, and we can run it through the assembly and then do testing. So along with that, we have test facilities in-house with a dynamometer that we had built for us that allows us to do that testing. So we can be fully closed loop on that cycle. Customer service, I read a book even before I started my business, because I always knew I wanted to be an entrepreneur. I'm sure that was your experience as well, that you knew it was going to happen someday. And so I used to read business books like a nerd. And I remember there was a book, and I can't remember the name of it, and I wish I could now, but it said if you want to be successful, you either have to be the technology leader, the low price leader, or the customer service leader. And if you can be one of those 3 things, you're going to be successful. Well, I'm never going to be the cost leader because we're making it in America. And I don't know that I'm going to be the technology leader because I don't have a kilometro rosso like Brembo does, where they literally have a red building that's 1 kilometer long that holds all their engineers. But I knew I could be the customer service leader. And so if you call us, there's a human being that's going to answer the phone, and that person will be incredibly knowledgeable and will be able to answer any question you have, whether it's purchase support or tech support. All of our sales staff are called on the weekend on the regular by people at the track asking a question, I've got this thing, what do I do? And so we knew that customer service was going to be where we were going to shine. And customer service, though, goes beyond just what happens when you get a phone call or an email. It's also in the product that we can offer. And so not everyone makes a brake for a Lamborghini Aventador. Not everyone makes a brake for a Leggera. Or there are a number of applications that I would consider customer service simply from the fact that we have it and nobody else does. Being able to make a product that is available 4 days from now so that you can make your race. And so we knew that if we had that ability, it would set us out and set us apart. Currently in our facility, we have 6 vertical turret lathes, which are great big machines that you lay the casting down into, as opposed to a lathe that's generally laid on its side. These are specific for machining heavy round things. So we have 6 of those, 5 vertical machining centers, 7 in-house castings, as I mentioned, and then in our aluminum cell, we have 3 dual spindle horizontal lathes and 2 vertical machining centers. All of our hardware, again, I mentioned, was made on Swiss lathes, which are highly automated lathes that were developed in Switzerland for making watch components. So they make very intricate small things very quickly and in high multiples. And so we bought some of those machines and it spits out our hardware. And then again, we had our brake dynamometer built and developed for us. And so that's the thing that gives you the pretty pictures with the orange glowing and the sparks and all of that. But it's an invaluable tool for being able to benchmark and see how you're doing in your development process. The next thing we want to buy is probably going to be automation, because automation will allow you to get more done in less space and less time. And space doesn't grow on trees, and we're pretty full in our 17,000 square feet as it is. We have some OEM relationships. If you were to buy right now, if you called up Honda Racing and bought one of the factory Civic Type R TC cars, it would come with Girodisc brakes on it from Honda. Anytime you call them for replacement parts, it'll be ours. And similarly, it's the same with the Hyundai Veloster and TC car. Those are our parts as well. And we have some talks going on with this company as well for that. Motorsport is really where we're focusing these days, and so I just put this slide in here to show you that every single Porsche Motorsport application we offer a product for. Similarly, we offer all the Lamborghini Super Trofeos, all the Ferrari Challenge cars, and that's a focus that we're pushing more and more towards is that professional OEM motorsports relationship. We have, as a result of these OEM inquiries and contracts, worked even more on our rotor optimization. And so looking at how the rotor connects to the hat, right? We use the drive pins right now, but we've also been experimenting with this tang drive setup where it's a tooth drive system, and we've been dyno testing that a lot lately. We've been working on our vane design inside. There aren't big gains to be found going to optimizing the vanes, but there's as much as 10%. And so when you're looking at winning a contract, and part of that contract is how long does it last, how long are the brake pads lasting, what's the temperature of your rotor, those incremental improvements in efficiency can make the difference between winning the contract or not. And so we've done a lot of CFD analysis. CFD stands for computational fluid dynamics, and it's basically modeling in the computer what the result could be if you did this change or that change. And so you can say, put in this much heat in this type of way, and then run it at this RPM, and then tell me how the air is flowing out of there, and tell me how much heat I'm actually pulling out. And so a lot of our work now is looking at how do we optimize what our current projects are, working with the foundry with their 3D printing capabilities and saying, hey, let's do this cost effectively and print us and pour us some of these that we think in the computer are doing really well. And then we'll take those back and machine them, put them on our brake dyno, and then we can back-to-back compare things and say, oh yeah, we actually are seeing what we thought we were going to see when we did this in the computer. And so having the ability to have all of those tools in the toolkit helps you to be effective engineers. We do, and it's this type of work, the simulation work, is very computational power intensive, right? And so we actually do all this through Amazon's AWS cloud services. And so all of this is done in the cloud. If you had one computer that you were running all of this analysis in your own shop, it would take months to run all that. And so we can do 12, for example, right? You've got these veins in here that lay over at an angle like that inside the disc. Well, maybe this angle is better than this angle is better than this angle. And so you might run 12 different sweeps of what those angles are. And each one of those takes hours in the simulation to crunch the numbers and tell you. So, and then you'll run 12 of those. But it'll happen overnight, and you'll come in the morning and you have the results, and you just paid Amazon to use their computers, and then they run it. The next thing might be how many veins are in there. Was 32 better than 40 is better than 48? And so we'll stack the veins up and then run the same simulations and see how that works. And so we're utilizing that kind of technology to help improve our product. And then lastly, as far as our facilities go, being in the Pacific Northwest, we're a very green, eco-conscious kind of place. And instead of greenwashing things and saying, oh, look, we're doing all these fun and fancy things. No, we actually, our packaging is, we have always tried to maintain that, you know, we're not putting foam in our boxes, or we're not doing things that are going to be detrimental to the environment. We recycle everything. We have a briquetter that briquettes all of our shavings from our aluminum manufacturing, similarly with our cast iron machining. We have our solar array on the building, and that's all part of our design philosophy as well. Is being a Boy Scout, leave no trace was always the thing, and so we're trying to be cognizant of that, because at the end of the day we understand that we're all going around a racetrack and burning gas and rubber and all of that, and so we're also trying to not make it worse on the manufacturing side of things. That's my quick overview of what the company is and what we do. I have another slide presentation that I do when I guest lecture up at the university that's much more nuts and bolts and kind of engineering related. But I'm happy to either go through some of that if you guys are more in the weeds on it, or if you want to ask some general questions, I'm happy to ask any kind of, or answer any kind of questions you might have for, in general, about brakes or car specific, application specific. Yeah.
I was wondering, when you do the simulations, do you see that like different numbers of vanes and the directions of the vanes change depending on the kind of car you're using, or is it pretty consistent?
So, sure. So a brake disc at the end of the day is a battery. A battery stores energy and releases energy. And so it's just not a battery like you would think of in your cell phone or in your, you know, or under the hood of the car. But it's still absorbing and rejecting energy. And so if you were going to start from scratch and you had a given weight and a given horsepower and a given usage of the car, you could calculate how many kilojoules of energy are going to be created in a braking event. And you kind of, after a while, get a feel for how much iron mass you need for a given amount of energy and usage that you're going to use. And so you can start to say, all right, this much horsepower and this much weight, I'm going to need a rotor about this size that's going to weigh about this much. And that's just something that you learn over time through your testing, right? Both empirical and in computer. Where it gets interesting and where the CFD analysis really comes into play is I'm restricted now with this size of wheel, and for us, in our case, the OEM brake size. What can I do to maximize now the thermal efficiency and cooling efficiency of that? And so that's where you really want to look at. The vane itself has surface area to it, right? And so the heat is coming off of that surface area, and the air is blowing by it and taking that heat out of the rotor itself. But you can get, so that leads to, well, 30 is not very good because it's getting too hot. Maybe we should put 100 in there. Well, if you have 100, now you have nowhere for the air to flow. So here's my two sides. How do I come into the middle where I'm going to find the right number of vanes with the right amount of surface area to be able to get the heat out in this given application? It gets pretty in the weeds. If you look at some NASCAR discs, before this current NASCAR where it's a spec car and they've got the center lock wheels that are much larger, well, now they're actually able to run a fairly good sized brake. But prior, they were running 15-inch steel wheels just 3 years ago. And those 15-inch steel wheels meant you had little baby brakes under there. And so they were like this wide. They were 46 millimeters wide, some of them, 42, 46 millimeters wide. And so they would fit as many vanes as they could in there, and there was very little space, and it was all optimized around this package. So you have constraints that you have to work with, but if it's a clean sheet of paper, you get a lot more freedom to be able to do things. Ideally, the way you do it is you keep making it smaller and smaller and smaller until it finally won't work anymore, and then you back up one step and you say, all right, we found the optimal size. Because weight is also a killer. You don't want additional unsprung weight, rotational inertia. So you're trying to balance those things. It's actually somewhat easy for us because we're always just stuck with what it is. I have to make it this size or it's not going to fit on the car and work where the factory piece was. So then you just optimize as best you can for that size. We have a niche in that we make a direct replacement two-piece rotor. If we were a big brake disc company or a big brake kit company where we were selling you a caliper and a rotor and a bracket, now we have to think about, okay, what am I trying to achieve here? How much additional brake cooling and brake torque am I trying to create that the OEM system didn't have? And so that's a whole different game that we don't get into, because what we're doing is just optimizing the original system. A lot of times, the OEM will, the manufacturer will err on the side of safety. And so the rear brakes frequently are an area where you can do upgrades and actually put more brake torque in. And this is something that you guys have done in the past, where you actually took the front caliper and put it on the rear rotor to exponentially increase the amount of rear torque. You can imagine that an original equipment manufacturer, an OEM, that they don't want somebody coming into a corner in the dark, in the rain, and having the back end lock up and slide around. And so they really limit the amount of rear brake torque. Even though you've got ABS, even though you've got proportioning valve or whatever, they're still saying, the best scenario for us is that the back end never comes around. Well, if you lower your car, you've lowered your center of mass, and now you've got less pitching moment, your rear tires can be doing even more work. And what's the first thing everybody does when they get their car ready for the track? Well, you're putting wheels and tires and lowering it and doing all these things. So you've got a completely different scenario than you did as a stock vehicle. And so there's always room for more rear brake torque, but that's nothing that we really get into because we're just doing the pads. Now, if somebody calls and says, just doing the rotors. If somebody calls and says, we want some pads, how might you help me with my pads to tune the car? Well, now I have, based on what our knowledge is of what our customers are doing, Porsches, Lotuses, whatever, we can say, hey, you can put a little more rear brake in this car. We know that it's notoriously under-braked in the back, so we can step up the rear pad. I would always recommend starting with the same pads front and rear until you get more feel of the car and you're in a more controlled environment. You can start experimenting. But when we're talking about just a direct replacement, that's the next thing you can do is to adjust brake balance of the car. You can start playing with the pads, and that can work. Yes, sir.
Hey, Martin, could you talk to us a bit more about the construction of your rotors, the slots, the lifetime, how to bed a rotor in, some of the fundamental basics?
Sure. So one of the things we did very first thing was we said we don't want drilled rotors. That was one of the reasons why we went and built this company, was because drilled rotors have a hole in them, and that's where the cracks start. So it's kind of a funny thing to think about, but the air in the hole doesn't expand, but the metal around it does, and so you've got only so much surface area there, and as it keeps going like this and growing and shrinking and growing and shrinking from turning orange to not being orange, that crack starts to form around the hole. And so we wanted to go just with a slotted rotor. One of the things we're learning right now, using our brake dyno, is how that slot can actually affect your initial torque. And so we're playing around with slot designs at this point. You'll notice these are all straight slots, but our latest offerings, we've switched over to a curved slot because the curved slot's actually offering a bit more initial bite on the disc. Cast iron is a fantastic heat sink, and it's inexpensive and it's very stable at temperature. And so that's why cast iron historically, and still is to this day, used as a brake material. We've experimented with aluminum metal matrix composite, which the Series 1 Lotus actually had on it. But the problem, and they're fantastic until you get them over 800 degrees. And at that point, you've reached the yield strength of aluminum, and you start shearing the faces of the brake material right off with the brake pad itself. So Series 2 did not come with those rotors. They put a steel rotor back, or an iron rotor back on. It has a slotted hole, or an oval hole in here, and we use a round drive pin. So as this expands from the heat, it is not restricted in the way that a one-piece rotor or a simply bolted rotor would. This is called a floating rotor, and that's accomplished by the oval hole that's in that mount flange. So the drive pin is the same diameter as the middle of this oval hole, and as it expands, it's allowed to migrate down towards the bottom edge of that hole. The four main advantages that we have over the factory one-piece disc is it's not drilled, it's slotted. It's lighter weight because of the aluminum center hat. It's curved vane going in the correct direction, and it's floating using our drive bobbin float assembly hardware. So the next part of your question was talking about bedding brakes.
Yeah, the importance of that.
So it's interesting because everything has a frictional coefficient, if you remember back to your high school science class days, right? And the friction coefficient is different depending on different things that might be present. So temperature can affect your friction. If they get wet, that can affect your friction coefficient. Pads can glaze on the face of them if the binders in there overheat too quickly when they're being bed in, and that can lower the friction coefficient. And so one of the things that we've learned from the dyno, because we used to just tell people kind of a generic bedding sequence, right? And all the pad manufacturers have the same one. It's like, go out and do a bunch of stops from 30 to 0, and then let it cool down a bit. And then go do some stops from 60 to 0, and get moderately more, or get more aggressive in your brake pedal, as you go. And that's a really good thing to do, because what you're trying to do is not introduce too much heat too quickly, but you're trying to transfer the pad material to the disc itself, because you have adhesive friction and you have abrasive friction. And abrasive friction is just like sandpaper dragging on something, abrading it. But adhesive friction is actually the pad material itself sticking to the disc, and then the pad material on the brake pad. And so now you've got that similar material that's actually grabbing against each other, and it's an adhesion. Think of it like glue almost, because you're trying to stick those two surfaces together. So what we're trying to do is put that pad material on the disc and have it stay on the disc, and use adhesive friction then to be able to slow the car down. Now what's interesting about race pads, though, of course, is that they get more abrasive material in there in the form of metal to be able to handle the higher temperatures. And so if you drive your your race pads on the street, you're back to using the abrasiveness of that metal that's in the pad, and it will grind away the transfer layer that you've bedded onto your rotor. And that's been an old racer trick for years, is put some really aggressive pads in and drive home from the racetrack, right? If you've got one of these cars or a car that's not a trailered car, and you'll scrub all that race material off the disc because it's cold and it's abrasive, and then you can put your street pads back in and it won't squeal as bad. But the thing that we've noticed and we've come to learn after bedding so many rotors and pads now on our brake dyno is that the size of the disc and the mass of the disc can make it easier or harder to bed in a set of rotors. You guys have it really easy. This is a tiny little disc with hardly any weight in it, and they will bed in lickety-split, no problem. You get a 410 millimeter disc for a Porsche GT3 that had the carbon ceramics on it, and the disc weighs 23 pounds, and it's got this wide of a face on the rotor. It takes a lot more energy, a lot more heat to get the heat built up to actually transfer the pad material. And so on the dyno, it takes a lot longer to bed a set of Porsche carbon ceramic discs than it would take to bed these. We'd have these done in 5 minutes, but that Porsche might take 15 minutes to get that pad material to actually go on there and look nice too. So the temperature control is something that you're trying to control in a way that's not overheating it, and you're gradually bringing that temperature up, and that's the best way to bed the rotors. If you have any kind of brake ducting on the car, it's always advisable to put a rag or something in your brake ducting, block it off so that you're not cooling the rotor as you're trying to heat it up and do your pad transfer. Different pads, there are different materials of pads, and without getting in the weeds, there's centered, materials and organic materials and the different kinds of binders that are in those materials. They all will play a role, and so there are different brands of pads that are historically known to be very difficult to bed in. And once they're bed in, they're fine, but they're harder to bed in. The Padgett Yellow comes to mind, right? That's a pad that has notoriously been difficult to bed, but once it is, they last forever and they work really well. Other pads, such as centered pads like the carbon Lorraines that you guys used to sell back in the day, the CL pads, how were they for bedding in?
Easy.
Yeah.
But they just ate your rotors and destroyed your wheels.
Yeah.
Finish. Anyways, yeah.
But a centered material always beds in super easy and really, and leaves a nice transfer layer on the disc. We actually use a centered pad just for bedding on the rotor because it makes it that much. Bedding the rotor on the dyno, it makes it that much easier, that centered material, and it plays well with the other pads that we then would sell, but we don't sell that pad to anybody. Any other questions? Yes?
I have two. First one's probably pretty easy. The second one might even be a little bit naive, but I looked up a couple of cars, right in the beginning, and when you're going down to the trim and the model, like the GTR says only V-Spec. Does that mean non-V-Spec cars?
Are you
They
saying
don't work?
on our website?
Yeah.
Okay, so if, yes. So generally speaking, if there's going to be a model under there that says only this one or that one, it's because they came with a different brake.
Type of brake.
Yeah.
Different size or something.
Yeah.
So that would mean you only have the V-Spec size or whatever.
Correct.
And the same thing on the Porsche I think it said base 4S. Is that two models or is it the base 4S only?
It would have probably been base 4S. I'd have to look and see which one you were talking about. But generally speaking, we will on our website delineate and say, for example, the Corvette Z06. Corvette Z06 will have its own brake unless it has a Z07 package. And so we'll say Z06, and then there'll be another category under that that'll say, as far as a model, it would say with Z07 package. So
Yeah.
both of them will be different brakes than what the stock Z51 Stingray had. But so it should be delineated and say if there was base
It
or
would
if it was
say you
4S.
could select it and it would work.
Correct. Yeah.
Okay, it probably means you don't make the brakes for those two I was checking. My other one is, like I'm not I don't drive at the track. I don't know that much about race cars other than how to watch them on TV. But I've had some, like putting, upgraded brakes on a street car. They're horrible. I ended up having to go back and take them off and put the stock brakes back on, which work fine, for a street car. And I'm just wondering, because you're obviously like a performance-based manufacturer, can you just speak a little bit about that?
Sure.
And
This goes all the way back to me being a kid building muscle cars, right? And you always wanted to go as fast as humanly possible, and you spent all your money on camshafts and carburetors and
but
all
not
this stuff.
stopping.
But never on stopping, right? But just because something worked really good on the racetrack didn't mean that it translated really well on the street, right? And so you learn that with the big cams and the big carburetors,
Oh,
and
yeah.
you're just driving around town puking gas out the tailpipe, and it's horrible, and it drives terrible.
Get a
and
red
it's
light, you're in
lurching,
trouble. Yeah.
right? And the same thing applies with the brakes. So I'd be a multi-billionaire if I had a brake pad that would do everything, right? That would make no noise and no dust on the street and then be able to run all the way up until the rotors are glowing white hot, right? Such an animal doesn't exist. And so what you're looking at is you have to tell yourself, be honest with yourself and say, Am I more on the race side of things, or am I more on the street side of things? And you can get a pad that will work fantastic on the street that doesn't make noise, but has really good stopping power, really good initial bite, much higher operating temperature. So if you want to get more aggressive on on the Ortega Highway, I would never recommend doing that. That would be highly illegal.
Yeah.
But those types of pads do exist. But it's very easy to be convinced, especially on web forums, where somebody's saying, oh, I put these pads in and I can go burn around the racetrack and they're amazing and I can drive home on them. Everybody has a different pain tolerance, right? And so there are pads that you definitely can go and do a track day with that will hold up no problem and not fade, and they will get you home. That's different. That's different than enjoying driving, to church on Sunday. So there are race pads that will not get you home, right? They absolutely have to have the temperature in them, or they won't make any friction. So yeah, that's where you have to be honest with yourself, honest with your installer, whoever is going to recommend the parts for you, or honest with my staff if you called and said, hey, I want this, and we can gear you towards where your pain tolerance is and say, if you want to be focused on the track, we've got the pad for you. If you don't want to ever go to the track, but you want something that's going to give you a lot more initial bite and higher operating temperature and more friction, you're willing to live with a little wheel dust, you're willing to live with the occasional squeal at 5 miles an hour just before you come to a stop, we've got that pad for you. If you want something that's in between and you're willing to deal with some occasional squeal and not maybe getting, the ultimate temperature on the track, we've got that middle ground pad too. But it comes down to not putting race parts on your street car. Right. You have to think about, what am I trying to do? What am I willing to live with?
Yeah, I mean, if I could add a couple of things to that. The OEM engineers who develop brake systems on cars have generally found the best compromise, for the vast majority of people. So rarely are you going to find something in the aftermarket that delivers a better compromise. What the aftermarket is very good at is narrowly focusing to the exact requirement that you want, right? So OEM, again, as Martin was saying, to get something that stops now, that doesn't dust, that doesn't make any noise, such an animal doesn't exist, right? So yeah, if you're just a street driver, oftentimes the OEM solution's gonna work perfectly fine. Yeah. Martin, maybe you can just shed a little bit of light. We absolutely just started this project, so I know that we aren't anywhere too deep into it, but maybe give these guys a bit of an overview about this ABS block, this distribution block project.
So I actually have, I have a visual aid. If I bring up my other, let's see.
So many of you guys know that as he's bringing this up, the Lotus has an ABS system that's pretty antiquated, the Elise and Exige, I should say, sorry. It actually comes out of it's a Kelsey Hayes solution, but I think Lotus slapped this ABS on the car because they had to. And they didn't choose the most sophisticated solution. So the distribution block, in fact, so we're starting to work on a little project here, so I'll let Martin continue to talk about this. Now he's got it up on the screen.
So ABS stands for Anti-Lock Brake System, and it saves your bacon when you've gone too fast into the corner. There are wheel speed sensors that will measure if one wheel is going at a different speed than all the others, and it will then adjust the braking pressure to those wheels to try and keep all the wheels spinning but stopping. It has to account for when the roads are wet. It has to account for when there's snow and ice. It has to account for when you have a different load in the back of the vehicle or not. In fact, the early ABS systems were just rear only on pickup trucks, and that was about, they wanted a different amount of brake when the truck was loaded versus unloaded, and so that was kind of the early days of that. There's a phenomenon called ice mode, and it's kind of now it's taken on an urban myth kind of mystique to it, but there are several cars that have ice mode issues, and what that means is that when you're on the racetrack, that is not a condition that the ABS was really designed around, right? It was designed around all the other things that you might encounter while driving on public roads. But when you're on the racetrack, that's generally speaking outside of the original algorithms that were written for these components. And so you get into a situation now where you're trail braking a car and maybe the rears, you're wanting to slide the rear end around a little bit, or you're driving it outside of those original intended parameters. And so the car thinks, I must be on ice right now because I'm not measuring, you know, these other things that I would normally see, but I've got different wheel speeds going on. I must be on, maybe it's mud or ice or something. And so it just starts freaking out. And your wheel torques, your brake torques go all over the place, and it generally means your stopping distances increase dramatically as opposed to decrease dramatically. And so the way it works, and if I look at this as a visual aid, I'll go around this way. These are your two inputs from your master cylinder, right? So your brake pressure is, you've got a rear brake system and a front brake system, and you're trying at all times to balance that as best you can so that all four tires are braking at their optimum. So you've got a rear circuit and a front circuit. Now I won't get into the complication of cross-car circuits because that's a safety thing, but for all intents and purpose, you've got two circuits going in, and then these are your four wheels coming out. And then you've got these solenoids in here that are varying the amount of brake pressure, the hydraulic pressure that's going to each caliper. So what we've decided is that we're going to eliminate this part of it, and we're going to make a block, aluminum block that looks just like this, and we have started on it. We have it designed now. We just haven't started machining. We're trying to figure out what kind of tools to buy to actually make those threaded holes with the tapers at the bottom. But we're going to put a old school proportioning valve right in the side of that and just eliminate all the electronics and all of the stuff that would try and save your bacon, and do it old school race car style where you've just got a bias knob in there that adjusts your front to rear bias. And so that way, if you're driving the wheels off the thing and the ABS doesn't know what to do with itself, in theory, what we're trying to develop is a direct replacement piece that's you're going to take this whole thing out and put just the aluminum block in there, and there'll be a knob right on the side of it, and you'll be able to then dial in the brake torque for your maximum brake event, your threshold braking event. And so you'll be able to keep the rears at just before locking up, keep the fronts just before locking up, and you'll know you have your bias right, and there won't be any electronics to interfere with you. These don't have stability control, do they?
No.
You wouldn't be able to do this with a Porsche. That would be because it's part of the stability control management system, and so you'd be really digging in and taking out a lot of the electronics. But for this car in particular, this is a fun experiment. We're going to see if we can actually do what we think we can do, and I'm pretty confident that we can actually. And so that that's going to be something that I'm actually kind of excited about, because it doesn't exist. Nobody's made anything like this before.
No one makes this, and we could use it. And just again for the crowd here, this is a race car solution. Okay?
Right.
Yeah. So if you're just driving to Cars and Coffee, you don't need this.
This Willwood proportioning valve in the middle is what we've actually taken the guts out of, and we'll go into the prototype block to see if we can make that work. There have been factory cars that did not have ABS in them that are modern cars. So off the top of my head, the Evo, was it 8 or 9 that had the RS version? I think it was Evo 9 RS.
Yeah.
And so it, instead of having the ABS system, had that little doodad right there. And that is a fixed pressure reducer. And so the two lines that came out of the master cylinder, they just screwed those right into the master cylinder, and then the brake lines came out for the rear brakes. And so that RS model actually had something similar in it, because they didn't want to have ABS in the car because it was a rally specific type version, even though it was a road going car. So we're kind of thinking along those lines of what it would be.
So we reduce pressure to the rears?
Reduce pressure to the rear, yeah. So there's some math involved there, but basically what's happening is, if in a perfect world you would, and this is what ABS tries to do, but whatever the weight is on each tire dictates how much brake torque you can make, right? If you put too much torque on a tire that doesn't have any weight on it, and imagine you're in a corner, right? Yeah. So now your two inside wheels have less weight on them than the two outside ones. And if you put the brakes on in that corner, those two inside will lock before the two on the outside will, because you don't have the same amount of weight. So the idea is that as the car pitches forward from your pitching moment around the center of mass in the middle of the car, your rears now no longer have that much weight on them, and so you're reducing the pressure. And so historically it was done with a fixed proportioning valve like that brass one on the end. That might have come out of a 70 Chevelle or something, right? Like that's how long ago they used to do this type of a pressure reduction to the rear calipers. ABS came along and said, all right, we're going to do this differently. We're going to actually monitor the wheel speed and then adjust the line pressure, which will then lower torque accordingly and try and keep the wheels from skidding. And so that's ultimately what you're trying to do.
But it's only front to rear, not left to right.
Generally speaking.
Yeah.
There are people that are tricky. There are racers that are tricky and will put different pad compounds left to right in the car or do things with the ABS left to right in the car because they know on a certain course they're going to be turning this way a lot. And so they'll actually dial the car in to turn in using the brakes. That's high level stuff though.
Is the valve going to be located inside the cabin, or is it connected to the master cylinder?
Not for the prototype one,
Okay.
but once we do it, we would be able to remote mount it.
Yeah, I would think that would be the long-term goal, because that's what you want. That's how you set it up. I think.
Yes.
Yeah, okay. Cool.
It would be similar to a balance bar, right? Yeah. Where you had the knob inside that you were doing it that way.
The TCR cars I've driven that have like the actual valve inside.
Yeah, that's what we have on the Draken.
So if you look back here, where's my, it's not a really good picture, let me see. Sorry, this presentation I brought just in case we wanted to talk more technical. Here we go. So this is a balance bar setup, and again, you're doing a similar thing. You're trying to keep the torque on the rear different than the front because of that pitching moment under aggressive braking. And so these cars have 2 master cylinders instead of 1 master cylinder, and so you're favoring the 1 master cylinder over the other by using mechanical advantage. So when he's talking about having a remote knob in the car, it's connected to this little jack screw right here, and you're actually changing the pivot point that the pedal force is coming in on. And so it's all about trying to have the maximum amount of torque that a tire can handle. And that varies depending on, are you turning, are you braking, are you do you have load in the car, what's happened? Fuel load is the big one, right? That's initially why this brake, if you never had weight changing, you could just set the brakes and forget it. But the original biased knobs that people were using in a race car were to adjust for fuel load and to adjust in case it started raining. So if the rain came and you were in the middle of a race, you could dial out some rear brake torque because now you can't, you just can't put that much to the rear. And if your fuel was, as the race went on, if it was an endurance race, you might lose hundreds and hundreds of pounds of fuel load over the rear of the vehicle or the front of the vehicle, and that would change your bias as well, so you'd want to adjust for that. Any other questions?
Yeah, thanks, Martin. Any other questions, guys?
I have a little story that I want to share that I think would actually kind of talk about why it's so important that your brand's made in America. I did global time attack for a while. I've spoken to you guys quite a bit. I have Girodisc on like almost all of my cars at this point.
Nice, thank you.
And I had a Stop Tech kit. I was sponsored by them for a little bit, and it actually exploded day one out at Buttonwillow and punctured the cabin and nearly killed me.
Wow.
And it was their new pillar vane rotors that I'm sure you know about.
I know.
And they were made in China or Taiwan, I don't know which.
Yep.
And they just would not take any responsibility for it, and it was totally the foundry issue.
The rotor came apart.
Yeah, I have a picture of it. It came apart in 4 pieces and punctured the inside of the cabin of my race car.
Yeah.
And from that point forward, I'll only run Girodisc on all of my cars. It was a scary moment, and brakes are so freaking important. Like even that could have happened on the street too. It wasn't even like that tense. It was lap 1 with brand new rotors on the car, and the thermal shock, something in the metallurgy wasn't right, and it just exploded equally in 4 parts.
Yeah.
And it was gnarly.
We had some sample pieces made. I was young and naive, and we were trying to figure out who our first, make-it-yourself rotor supplier was going to be. And we got some parts from Taiwan, and I had them metallurgically tested.
I'll show this to you.
And the metallurgy place called and said, "Are you sure this is brake rotor material that you sent us?" And I was like, "Yeah, no, this is one of the samples." And he said, this looks like lawn furniture or something. Like, this doesn't look like brake rotor material. So we have seen beautifully machined and finished brake discs on the market. You can buy $300 pairs of rotors on Alibaba today for your Audi and go put them on. Just because they look pretty does not mean that the secret sauce is in there. And for most people, if you're driving around town, going to 7-Eleven, whatever, not a big deal. But you never know when you're going to need them. You never know when it's an emergency situation. You never know when you're going to go down the grapevine and somebody's going to pull out in front of you and you got to slam on the brakes. And
I'd argue it's more important to have a good set of brakes on a street car because in a racetrack you go straight off.
Yeah.
Usually, and you
Hey, it's not just brakes.
Can't do that
It's
on
almost everything. The quality of some of the stuff you get, it's, I think I've seen everything. No, I haven't. And it's like, you know, like I was with British Leyland back in the day, never known for quality. It makes their stuff look like aviation quality compared to the crap you get now. And it seems to come from almost everywhere.
we're actually making, you would not know this, and I can't tell you their names, but we make for some big name brake companies, we make rotors for them for the North American market because
For that reason.
they've had trouble with overseas suppliers. There are good overseas suppliers. It's not
I'm not saying everything.
It's not that everything
I'm not
over
saying
there is
because
garbage.
it's from China, it's no good. But I'm telling you, it's almost unbelievable the crap you get. It's not brakes. It's like gearbox parts. They're not hardened. They fall apart. It's unbelievable.
But that's a mindset and a value, right? And that's a value of our company is to, like I said in the very beginning, is only try and do it the very best you can do it. And if you're going to accept anything less than that, you better have a really good reason why. So.
Well, those rotors,
Thanks, guys.
they sold for $99, so I should have known better. But it came with
You
the
get what you
big
pay
brake
for,
rotor
Kevin.
race
You
car.
get what you
Like,
pay for, man.
well, no, you're 100% right, but like they sold that as a race kit,
Yeah.
and they were partners with me, and they actually sent that to me.
We've
It's
had
nuts.
exactly the same thing in the Lotus market. You know? So, anyways, any other questions, guys? If not, well, thank you for coming. Martin,
Yeah.
thank you so much.
My pleasure. My pleasure.
We got pizzas and sodas next door, but Martin will be here, so if you have any more specific
Yeah,
questions, you can
absolutely.
certainly, we can get geek out in the weeds here if you like.